Let's talk about equally likely outcomes. Let's imagine that this is your sample space. And here we have a few equally likely outcomes. This is one of them, this is another one, third, fourth, fifth, sixth, seventh, eighth, ninth, 10, 11 and 12th. So we have 12 equally likely outcomes that cover up the entire sample space. Okay, so what does our intuition say? What do you think the probability of any single one of them is? Pause the video, think about it. What's the probability? Well, if all of them are equally likely and the sum of all the probabilities, which is the probability of the sample space, that's 1. So that's going to be divided equally amongst all 12 of them. So this P should be equal to 1 by 12. And that's the right answer. But we're also going to prove this using the axioms that we discussed in the previous video. Okay, let's do this step by step. The sample space is S and we have these 12 equally likely outcomes. We know that the probability of each of them is the same. They're all equally likely, and that's by definition because that's exactly how we have defined these orange events. We also know that the probability of the sample space, this entire sample space, is 1. We know this by our axiom 2. So what we can do is we can replace this S. We can say that this S is the union of all 12 of these. So we can say that this S is the union of W1 and W2 and W3 and so on to W12. This means that the probability of union of all 12 of them is equal to 1. And here comes the fun part. We know that all 12 of them are mutually exclusive. There is no overlap. And because they're mutually exclusive, we can use our third axiom and say that we can break this probability down as the sum of individual probabilities. We can say that this is equal to the sum of each probability. Probability of W1, probability of W2 and so on. This is also equal to 1. We can say that by axiom 3. All these probabilities are equal. Let's say that that value is P. So we have 12 P's, all of them adding up to 1. So 12P is 1 and that means P is equal to 1 by 12. So your intuition was right. The probability is 1 by 12, but this is how you prove it using the axioms that we have discussed. And by the way, there is nothing special about this number 12. We can generalize this. In general, for n equally likely outcomes, if there were n such events which were mutually exclusive and exhaustive, we can say that the probability of each of them would be equal to 1 by n. This is the probability for every single one of them. Let's take this one step further. Let's say we have a bigger event. Let's say we have this green event, which is the combination of these smaller 6 equally likely orange events. What do you think? What is the probability of this green event? Well, you might say that this green event is 6 times larger than this orange event. So the probability should be equal to 6 times 1 by 12. That's 6 by 12, which is equal to half. But let's break the steps down. If the sample space has 12 equally likely outcomes and an event E has 6 of them, the probability is 6 by 12. And now we can generalize this. If the sample space has n equally likely outcomes and an event E has m of them, then the probability is equal to m by n. So the probability of any event E is equal to m by n in the case of equally likely outcomes, where m is the number of favorable outcomes and n is the number of total outcomes. You might have seen this written in one of your earlier textbooks, maybe in your 7th or 8th grade, and this is where it comes from. Okay, so let's quickly practice what you've just learned. Let's say we have this scenario where a coin is tossed 3 times. And let's say we have these 3 events. Event A is when no head appears in all 3 of them. Event B is when exactly 1 head appears. And event C is when at least 2 heads appear. Find the probabilities of all 3 of them. Pause the video, think about it. Okay, so let's do this together. The first step is the same. Let's figure out the sample space. So when you toss 3 coins, you can get no head. You can get all 3 of them as tails. Or you can get 1 head. Maybe the last one is head, maybe the middle one, or maybe the first one. These are the cases when we have 1 head. Or you can have 2 heads when you have these 2 or these 2 or these 2 as heads. or you can have all three of them heads. Okay, so this is your sample space. Now let's look at events. The first one is event A, where we have no head. That's the first one. And because all of them are equally likely, we can say that the probability of this event is 1 by 8, because there are 8 such events. Similarly, for exactly one head, we have these 3 events and all of them are equally likely. So the probability is 3 by 8. And for at least 2 heads, we have these 4 events. All 4 of them are equally likely. Probability is 4 by 8. That's how you calculate the probability in case of equally likely events.